The perpendicular height, AC, of the cone below is 2 meters. Okay, so we've got 2 meters over there, and the radius is r. AB is the slant height, and the angle is 36 degrees. For 6 marks, calculate the total surface area of the cone. So when you look at a cone, you've got a circle at the bottom, okay, so that's got pi r squared, so the formula will be pi r squared, plus, then you've got this stuff that's on the outside of the shape. To work out the surface area of that, it's pi radius slant height. Okay, so that is the formula that we will use. This is actually a pretty straightforward example because there isn't, for example, another shape at the bottom here where we have to, when that happens, when you've got multiple shapes combined, then often this will have to change a little bit. For example, you might have to leave this out or stuff like that. Okay, but this one's straightforward because it's a single shape, a cone. So, okay. Let's see what we need to do now. Okay, so we've got the slant. Okay, no, we don't have the slanted height, but this is fine. Because we got an angle and it's a 90-degree triangle, we will go back to grade 10 trigonometry, not grade 11. We use grade 10 trigonometry. And, I mean, you could use grade 11 somehow as well. That's fine, but it's not necessary. So we could just use, well, I like to use SOHCAHTOA to remember what sin, cos, and tan will be. So we've got this angle, okay? We've got this side already. So that's called your adjacent. So we have the adjacent, and we need a couple of things here. We need the slanted height, and we need the radius. So let's go find the radius first. So that is your opposite. It's opposite this side. So tan is the one that we will use. So the way that we'll do this is we'll say that tan of 36 is equal to opposite over adjacent, so R or BC over adjacent, which is AC, and that then becomes tan 36 is equal to R over 2. Now to get R by itself, you're just going to take that 2 and multiply it over, so we end up with R is equal to 2 tan 36, and so R will be R are going to be 2 tan 36, 1.45, meters. Did they use meters? Yes, 1.45 meters. Now you have two options. You could use Pythagoras now if you'd like to with the 2 and the 1.45 to give you this number, or you can just use trigonometry again. I'm going to use trigonometry again, and so now you could use this one, or you could use this one. I like to use what we've already been given, so that'll be the adjacent, and we're looking for the hypotenuse, and so that's A and H, which is cos. Why? Because. Okay, so cos 36 is so lame given. Cos 36 is equal to adjacent, which is AC, over hypotenuse, which is AB, and so that'll be equal to AC, which is 2, over AB, which is our slanted height. Okay, now some learners struggle with this, like how do we get this by itself? It's a two-step process. You're first going to take this over to the left, like we did here. So it becomes S cos 36 equals 2, and then you just divide by cos 36. So you end up with 2 over cos 36, and that'll give us 2.47. 2.47 meters. Let's go fill that in. 2.47 and 1.45. If you use the Pythagoras method, you might have gotten a slightly different answer. Okay, but for this answer that we're going to get, I'll show you the range of answers that you are allowed to get. Ooh, I went and erased our formula. Surface area equals to pi r squared plus pi r slant height. Okay, so now we can go fill everything in. So pi radius is 1.45. Let's write this a little bit nice or neater. 1.45 squared plus pi times 1.45. Slant height 2.47. Go ahead, type it all in, and we get 17.86 centimeters. Whoopsie, just joking, meters squared. Now, if you used Pythagoras, you might have gotten a slightly different answer. So you are allowed to get anywhere between 17.86 up to 17.92.